Okay, we're adding some more justifications to our proofs justifications list. So you should add these to your bank of justifications at the front of your notebook. So the first one is the definition of complementary angles. So what does it mean for angles to be complementary? If I told you that angle 1, I am going to go ahead and type this just because I don't want my handwriting to look so ugly. If I told you angle 1 and angle 2 are complementary angles, what would that allow us to say? What does it mean for angles to be complementary? If they're complementary, then we can say they have to add up to 90 degrees. That's what it means for angles to be complementary. That is the definition of complementary angles. So if my first step says angle 1 and angle 2 are complementary, then my next step can be, oh well, then the measure of angle 1, not A, plus the measure of angle 2 should be equal to 90 degrees. And that is the definition of complementary angles. If they're complementary, then they add up to 90. The converse of that is true. If my first step is, I'm going to change this font to red, if the measure of angle 1 plus the measure of angle 2 equals 90, if you know that the sum of those two angles is 90 degrees, then your next step can be, well then, angle 1 and angle 2 are complementary by the definition of complementary angle. So it works in both directions. Remember, definitions are true in both directions. So if you know they're complementary, then you can say that they add up to 90, or vice versa. If you know that they add up to 90, then you can say that they're complementary. Both of those would use the definition of complementary angles as your justification. So the definition of supplementary angles is very similar, except instead of adding up to 90, they're going to add up to 180. So if I said angle 3 and angle 4 are supplementary angles, if I tell you that, then you can say, then the next step can be, oh well, then the measure of angle 3 plus the measure of angle 4 has to be 180. And then the converse of that is true. If you know that the measure of angle 3 plus the measure of angle 4 is 180, if you know the sum of those two angles is 180, then by the definition of supplementary angles, you could say, oh, well, that means that angle 3 and angle 4 are supplementary angles. So if you know the two angles are supplementary, then you can say by the definition of supplementary angles that they add up to 180, or vice versa. If you know that their sum is 180, then by the definition of supplementary angles, you can say that they are supplementary. And then finally, linear pair theorem is if you see in your picture that two angles form a linear pair. If you see that two angles form a linear pair, you are allowed to say that they are supplementary. So you can say, if you see that in your picture, then you can say angle 5 and angle 6 are supplementary, and your reason would be linear pair theorem. So this is one of the most common mix-ups that people have. They want to jump in and say, based off this picture, they want to go ahead and say, oh, measure of angle 5 plus measure of angle 6 equals 180. That's what they want to go ahead and say straight off the bat from seeing that picture, and that is not, ooh, yikes, that is not how it works. That is not how the linear pair theorem works. The linear pair theorem says if two angles form a linear pair, so if you see in your picture that they form a linear pair, if they form a linear pair, then by the linear pair theorem you can say in words they are supplementary. The angles are supplementary. Or supplementary angles, I'm sorry. Supplementary angles. There we go. So linear pair theorem says if they form a linear pair, then they are supplementary. Cool. Let's look at this first proof. So it's telling me that the measure of angle CDE is X, the measure of angle EDF is 3x plus 20, and then that ray DC and ray DF are opposite rays. And that's just trying to tell me that that is a straight line. Ray DC and ray DF are opposite rays means that that's a straight angle. So I know for a fact that that's a straight line. So first thing I always put in a proof is the given. So that's my given. Then I see, since this is a straight line, I see in my picture that that angle CDE and angle EDF form a linear pair. Those two angles form a linear pair. Because I see that they form a linear pair, now I'm allowed to say, oh, if they form a linear pair, that means that they are supplementary, and if they're supplementary because of the linear pair theorem. Those two angles are supplementary by the linear pair theorem. Now that I know that they're supplementary, what does it mean for angles to be supplementary? It means they add together to equal 180. So because I know they're supplementary, now I can say that they add up to 180 because that is the definition of supplementary angles. Because they're supplementary, then I can say they add together to equal 180. These two steps right here are really commonly mixed up. First, you see their linear pair. If they form a linear pair, then they're supplementary by linear pair theorem. And then because they're supplementary, then you can say they add to 180 by the definition of supplementary angles. Okay, now I'm going from an equation with angles to an equation with variables and numbers. I am taking the x, plugging it in, taking the 3x plus 20, plugging it in. Plugging stuff in is called substitution. Okay, next I see I have an x and a 3x. I'm going to combine like terms to get 4x plus 20 equals 180. When I'm just combining like terms, that is simplify. Then to get to the next step, I'm going to subtract this 20 from both sides. When I'm subtracting a number from both sides of the equation, that is the subtraction property. I'm subtracting 20 on both sides. And then finally, to get from 4x to x, to get from 160 to 4, oh, that should say 40. Whoopsies, little typo there. That should say x is 40. Oh well. I would divide both sides by 4, so that's the division property. I check my last step, x equals 40. Now it matches my proof statement perfectly, and there we go.